Okay, let's dive in. We're going to unpack one of those fundamental problems in professional video.
Right.
How do you get a massive, high-speed video signal from point A to point B when they're miles apart without losing a single pixel?
And that's exactly what this piece of kit we're looking at is designed to do. It's the Thor Broadcast F-M2SDI-Tx RX.
And it solves a very specific, very hard limit.
It does, the 100-meter barrier. With standard copper coax cable, your HD-SDI signal is basically dead in the water after about 300 feet.
That's it. And that's a physical wall. It's not something you could just boost your way out of.
No, not really. That limitation is a huge shackle for big venues, stadiums, broadcast centers, that kind of thing.
But this technology,
Yeah.
this just smashes right through that wall.
Oh, completely. We're not talking about just adding a few more feet. We're talking about a leap. This kind of equipment, like the Rattler products it competes with, uses lasers to just fire the signal.
To an incredible distance.
An incredible distance. We jump from 100 meters to, well, potentially over 80 miles, 130 kilometers.
And this specific kit, the FM2SDI, is rated for 20 kilometers right out of the box. That's, what, a whole university campus?
Easily. Or linking a downtown studio to a satellite uplink facility way out of town. It's a game changer.
So to do that, you need some pretty specific optics. The spec sheet mentions 1310 and 1550 nanometer wavelengths. Why those two?
Okay, so that's the really efficient part. Using two different wavelengths, two different colors of light, essentially lets you do something called wavelength division multiplexing, WDM.
So you're putting different signals on different colors.
Exactly. You can send your video out on one wavelength and get a return signal back on the other.
All on a single strand of fiber.
A single strand. It's a massive saving on infrastructure.
Okay, so we've got the range, the pipe is there. What can we actually push through it?
Well, and this is what's really impressive. It supports two full, independent HD-SDI streams.
Two at the same time.
Yep, simultaneously. Each one running up to 1.5 gigabits per second. Two high-def video pipelines running down a thread of glass.
And it's not just the picture, right? Broadcast needs more than that.
Of course. It carries the two channels of embedded audio for each stream, plus all that critical ancillary data.
Things like timecode, closed captions.
All of it, control triggers, everything. But you probably noticed the little caveat in the manual about the audio.
I did. It says you can use embedded audio or our external analog if you get the optional cards, but not both at once. Isn't that a bit of a headache for a workflow that already has, say, an external audio mixer?
It can be, sure, but for a lot of these point-to-point links, the simplicity of having everything embedded in one signal is actually the goal.
Makes sense.
But the real intelligence here is the control path. It has a return path serial channel, an RS-485.
So that lets you control things back at the other end.
Precisely. You're at the receiver, miles away, and you can control the pan, tilt, and zoom on the camera connected to the transmitter. It makes remote operations actually practical.
Right. That two-way communication is key. So for the people actually installing this stuff in the field, what matters?
Reliability.
Reliability. And I see they've thought about that. They use locking connectors.
Oh, you have to. BNC for video and ST or FC for the fiber itself.
I mean, anyone who's ever tripped over a cable in a production truck knows that a simple pull can take you off the air.
Yeah.
That's a $5 feature that saves you thousands.
Absolutely. And that extends to the diagnostics, too. You get these link alarm indicators on both ends.
So you know instantly if the problem is the fiber link itself.
Yeah, you're not guessing. And the whole thing is built to operate from freezing all the way up to 70 degrees Celsius. It's made for tough environments.
So really what this all boils down to is a kind of universal translator. It bridges your standard local copper video world with the ultra long distance world of fiber optics.
It's the piece that solves that final mile, or in this case, final 80-mile problem.
It ensures that broadcast quality video can get basically anywhere you can run a single strand of glass.
Which leaves you with a really interesting question for the future, doesn't it? Well, if we can push two 1.5 gigabit streams this far today using just two wavelengths, what happens next? When you're talking about live 4K or even 8K, the bandwidth needs just explode.
So what's the next breakthrough going to be?
Exactly. What new multiplexing techniques or new parts of the light spectrum will we need to unlock to keep pace? That's the challenge that's going to define the next generation of this tech.